Our first keynote speaker this morning is Andrew Waugh, a founding director of Waugh Thistleton Architects in London and a renowned architect. Andrew has been building with CLT for 15 years. Waugh Thistleton designed the world's first tallwood CLT building, Murray Grove, in 2009. He was also responsible for the first urban housing project to be constructed from prefabricated solid timber, for which he was awarded the Royal Institute of British Architects President's Medal for Research. Andrew is a true pioneer in the use of mass timber. Would you please join me in giving a warm welcome to Andrew Waugh?
Thank you. Morning, everyone. Excellent. So this is us. We are Waugh Thistleton Architects. We're an architecture practice based in London, in East London. And we design and research and build in timber. The reason why we do that, right back to the original sketch, the reason why we do that, why we started to look at that, was all about climate change, all about trying to understand, as professionals, what the impact was of our actions on the environment. What were we doing, and what was the carbon footprint, what was the carbon count of the work that we were doing. Now this is a graph from Turner's Construction, and this shows that if you build a building now in 2018, the way that US and UK regulations work, and that they count the carbon footprint of a building, and bear in mind, I'm not sure in the US, but in the UK, just under half of all greenhouse gas emissions are down to buildings, and about a third down to construction itself. So if we look at the time value of carbon, so from this Turner's diagram, over a building, over 50 years, which is how a carbon footprint is calculated at the moment, over 50 years, over half that building's carbon footprint is from the operations, so from the heating, ventilation, air conditioning, from the lighting, from the powering of that building. So that's the carbon footprint after 50 years. It's over half of that is down to those things. But actually, only just under half is down to the materials that build that building and the processes of construction. And in fact, if you wind back to the Paris Accords, if you think about the Paris Accords, which you guys signed up for as well so far, and which will stop us, because if we're here in 30 years, then actually we'd be here under about 1 meter of water, just in the Bay of Boston. So that's an interesting idea. But if you look at the Paris Accords, just to meet the Paris Accords, we don't have 50 years, we have 17 years. And if you wind that back, that carbon footprint back to 17 years, actually the building materials on a typical multi-story residential building, the building materials represent over 2/3, and the process of construction over 2/3 of that building's carbon footprint. So as architects, as engineers, as contractors, developers, manufacturers, and even lumberjacks, anybody involved in the construction industry, if you don't want to be part of the problem, but you want to be part of the solution to this, then you need to be building in timber. So we built the first, as I was saying, we built our first building in the UK in 2003, and we had ideas around sustainability, and we had ideas around prefabrication, and I started in practice straight from college. And I went straight out of college, straight into thinking, right, I'm going to build buildings. But I didn't have a clue how to do it. And then you realize the more that you're involved in construction as an architect, actually the less that you have to do with construction. And that didn't really appeal to us in our early days of practice. We felt that actually what we drew is really what we wanted to see on site. And so the idea that we would prefabricate that we would reduce our carbon footprint, that we could increase our connectivity, if you like, with the construction process, is what first led us to working in CLT. That and an ad that we saw in the back of a magazine. So we built this little building, 45 square meters, what's that, 500 square feet, 3 stories, and 4 people built that perfect little building on a Saturday afternoon, and I sat in my car, and I watched them crane it in and screw it together with a cordless screwdriver. And I was just, I bowled over. And then 5 years later, we started on Murray Grove, on Stadhaus Murray Grove, which is a 9-story building, 8 stories in cross-laminated timber. The elevator shafts, the staircases, the external walls, the internal walls, and the floor slabs, all constructed entirely from CLT. Now, we'd done a couple of houses in the meantime between 2003, 2008, but this was part of a study, part of an idea that we worked through with Technica engineers, with KLH at the time, part of an idea to really see what this material could do. That actually, if you think about the problems of our age as an architect, the problems of our age are urban housing and the international global urban housing crisis. As we all move into the cities, and as some of the mistakes of the 60s and 70s really begin to kind of appear, actually the global housing crisis really is what is pressing on all cities. And at the same time with climate change, so the idea that we could begin to look at an urban housing solution which didn't exacerbate climate change, where you could use timber, which was actually a carbon store, where you could begin to do that, you know, was an exciting notion to us. And this construction, you know, the calculations were done with a calculator and a pencil and a piece of paper, and it's kind of like, you know, and there's an awful lot of timber in this building, I have to say, which made it very popular with a lot of timber people. But we've, you know, and we've come a long way since then, but still understanding a lot of the simplicity of the details of this building, I think are actually essential in moving a technology forward. So you can see just kind of like the whole building's put together with a 3-inch galvanized shelf bracket and a 5-inch screw, you know, and then the electrics go in here on a plastic tie, you know, and the whole thing, incredibly simple, incredibly straightforward. One of my favorite stories, oft repeated, is that on the first few days of the electrician being on site, the guy's walking around on stilts, and I see him on site, and he looks down at me, and he says to me, "Look at this, look, we've nearly finished the whole building. So we're supposed to be here another 6 weeks, and we nearly finished the whole thing." And then he began to explain to me about when you apprentice as an electrician. And when you apprentice as an electrician in the UK, you spend about the first 18 months hammer drilling into concrete. And after about 18 months, your shoulder joint begins to disintegrate. And when your shoulder joint is disintegrated, then they teach you about electricity. So we began to understand the beginning of an understanding about the implications of changing a construction material, the implications of taking out concrete and steel and building with timber, building a prefabricated construction method with a completely different material. But the implications go wider than sustainability. The implications go wider than these buildings might first suggest. So you can see over 1,000 tons of carbon dioxide just saved within Mother Nature's perfect invention of the great carbon storage tree. 27 days, 4 men, cordless screwdrivers, put this whole building together. No tower crane, really quiet, very few deliveries, about 80% reduction in construction deliveries to site. And as I was saying, incredibly quiet for an urban condition. That's so important as well, that we were building this building literally sort of 30, 40 feet from neighboring properties with no complaints during the construction process, and fast. So the entire building was finished in 11 months. So from demolition to completion in 11 months. And it's light. So the structure of this building weighs 20% of what a concrete and steel building would weigh. So you can understand the implications in terms of foundations, etc., on a building like this. So that finished in 2008. And you know what, brilliantly, I do a little talk down here every September. Not this September, because it was really, really raining. But most September. And we have, last year, we had about 450 people standing down here and round the building in a tour. And I talk about the building like this. And there's a guy who lives here, who's lived here since it was built, and he's got a parrot, and the parrot sits on the balcony like that. And when I did the talk a couple of years ago on this beautiful sunny day, or a similar one, the guy leans out of his balcony and he says things like, "It's all made of wood." Stealing my thunder. And other really helpful things like, I've never used my central heating, and I can't hear my neighbors, and other great things like that. And so encouraged by this, in 2012, with my friends Jason and Dan, we bought a piece of land in East London near the canal, sold our flats, sold our cars, some of our children, and we bought this piece of land. And then to pay for the building, we had to then begin to sell off some of the floors below. And we sold this floor here to a photographer. And the photographer said that they needed an open studio 6.5 meters high, 26 meters long, 9.5 meters wide, with no columns and no beams. So the whole notion of that cellular construction that we looked at with Murray Grove was really kind of blown out the window with this. So what we did was to begin to understand the strength and the lightness of this material, to realize that actually a cross-laminated timber wall can act as a massive deep beam. And if you have these deep beams stretching across the building, then you can begin to utilize those to carry the floors. So these party walls here, they act as deep beams, and they carry these floors above this open room here. So these deep beams then tie into the front and the rear elevation, which act as massive, as giant trusses, if you like, that hold these beams up. So what we're beginning to do here is to see how the architecture of a building can be influenced by changing the material. So in many ways, Murray Grove is a concrete building built of timber, whereas Whitmore Road, what we had begun to do here is to begin to understand what kind of building we could build and can build using this new material. And I still live here. I was going to live there, but then Dan had an argument with Jason, so I had to move into the middle. So I live there still. So this is it here, the structure going up. And you can see we're learning other lessons as well. So rather than having big panels of cross-laminated timber and cutting a little window out and wasting all that material, what we're beginning to do here is to learn how to use less material. So we're using the laminates of the cross-laminated timber in the direction that they're needed. So we have really, in effect, giant columns and beams across the top here. You can see the floor slabs running through that. And then with the cladding on, and I've lived there, well, 6 years. Well, that went quick. And so last year, we finished another project, big project. We've now built 19 CLT projects, and we have 6 on site currently. So this one we completed last year was Dalston Lane. So this would have weighed 10,000 tons in concrete and weighs less than 2,000 tons in timber. And you can see here, 10 stories high, the large openings here for these windows here. So 121 apartments, 38,000 square feet of offices and studios, just over 100 feet tall, and the entire structure completed in 5 months. In fact, you can see how fast it was, because by the time the train's gone past, the building's finished. So here, finished at the end of last year. And now home to 800 people. 800 people live and work in this building, and 2,325 trees were used in the makeup of this building. So that's less than 3 trees per person, just to put this into perspective. And last year, we finished another project for a shelving manufacturer. This is a factory in the Midlands in the UK. And what's particularly interesting about this building, not only are we beginning to move as a practice, beginning to kind of diversify in terms of the types of brief we're getting, but also beginning to look at using new materials. So using different types of timber. So we've been using CLT, as I was saying, for the last 15 years, and really gaining quite an understanding about what that material can do and how we can work with that material. But now also beginning to look at LVLs, laminated veneer lumber, the kind of strength that you can get from those. So this building, the brief of this building was to really work very much like the shelving that the building manufactures. So the idea behind this shelving is that it's very expensive. You can you take it down, you move it from house to house. When you move, you take the shelves with you. So this shelving system, beloved of architects, was designed by Dieter Rams in 1960, and is an absolute design classic. So you have the idea behind this building is that this building can be demounted, it can be adapted, it can be moved from site to site, or actually changed within depending on what the function is. So you have this large external softwood CLT shell, if you like. And then inside, in the factory floor, you have a hardwood LVL beam and post system. And the tolerance on this is less than 1 millimeter. So I don't know, that's about a thumbnail in Imperial. And you can see the beams here of the LVL. These are spare beams. So when the client wants to put in a mezzanine here, or to change the floor configuration, they can slot these beams into the columns here and build new floors. So that span is a little over 75 feet, and the depth of the beam is less than 2 feet. So you're getting a beam strength in terms of its actual size, which is equivalent to steel, but you don't have to fire protect it. So you can see here kind of like how beautiful these are, and the tolerances, how exact and precise they are. These little notches here left open for servicing in the future. And because the building's so light, there's no kind of really sort of like traditional foundation. So in fact, the whole slab is just a stabilized earth slab. So we just plowed some cement into the soil for about 1.5 meters down, and then put a screed on top. And there's just a pad foundation, little pad foundation under each column. So very simple, very straightforward construction. And as I say, 8 months to build from start to finish. And you can see now. So not quite traditional factory in the sense that this is a restaurant, there's a ballet school, and then there's a factory. You can see here so this is another project we're working on at the moment. And this is kind of a bit of a departure for us because we're beginning to use some steel. And what we've done with the steel here, so this is all, is that the height of this building was incredibly important. And what I should probably explain is, unlike other countries in Europe, in the UK we really don't have very many planning laws around sustainability or around carbon. And the regulations are very low. So every one of our buildings in the UK, we have to prove on the basis of cost and program. We have to demonstrate to our client that each one of these buildings is faster and more cost efficient than building in concrete or steel. And with this project, we went to the client and we designed 3 separate buildings, one in steel and reinforced concrete, one entirely in timber, and one in steel and timber. And the steel and timber came out much faster and much more cost effectively than the other 2 options. Also, we were able to reduce the height of the building by just under 4 feet as well, which counted for a lot in this context. So you can see that the building here, we can run services through the beams here, through the castellated beams. And these beams, in fact, are just taking the load of the building. And because the building's so incredibly light, that steel can be vastly reduced from what it would have been with a concrete floor slab. And then we've used timber for all the kind of shear forces and for the core and for the external walls of the building. So the steel is just taking the vastly reduced load. And then we made sure that all the steel is standard sections. It's all bolted, not welded, so it's very easily demountable as well. And so this one's, 42,000 square feet and 10 months from start to finish. And that finished. In fact, I live just up there. It's my house. Keep it local. And we're looking at a number of other projects. So this one here on the drawing board, which is a hardwood LVL CLT building entirely made from timber. And what's been particularly interesting about this one is understanding the implications. You know, it's a 110,000 square foot city office building, 10 stories. And what we're able to do, because we don't have any concrete in this building, we don't have any concrete that we need to cool down. And we don't have any concrete that we need to heat up. So in effect, this building is very easy to heat and very easy to cool, because we can naturally ventilate the whole building. So what we have are these little kind of slots here in the structure that give us that opportunity to bring fresh air in and bring it round. Because actually, you're not having to heat or cool down the structure of the building. You're just having to change the air. You understand? And this building, again, we start on site here in this building at the beginning of December. This is, again, about 40,000 square feet, 6-story office building. And this one is built entirely from timber from ground floor up here. So this is hardwood beam and post and softwood CLT slabs and softwood CLT core. And this will be start to finish in about a year. So we're seeing more and more office buildings now. So we have 5, 6 office buildings on site at the moment. And that's very exciting because what's happening is that people in the commercial market are actually coming to us now and asking us to build them timber buildings. Because quite frankly, what they realize is if they have a timber building, they can rent that building for more than they can rent a concrete and steel building for. Because people in timber buildings are happier people. People who work in timber buildings work for longer hours, they have better concentration, they have reduced heart rates, reduced stress levels. People who sleep in timber buildings get to sleep 20 minutes more a night. So that's why I feel so good. So this is very exciting for us because this is beginning to really change the dynamic of our practice in terms of people coming to us and asking for timber buildings. Now, if you think for a typical office user in the UK, in the City of London, about 80% of their turnover is just through staff cost, and retaining those staff and treating those staff well is an incredibly important part of that business. So that kind of biophilic relationship that those office workers have with being around a natural material is incredibly important and is something that we're managing to actually commercialize in terms of pushing forward a timber architecture. And now I want to talk to you about productivity. Ironically, this is a diagram from McKinsey, which they would have showed later had they been here. And this is actually the best diagram of their whole talk. So, so don't worry about it. So this is about productivity. Now, this is brilliant. So productivity, look, 1966, that's when we won the World Cup. Right? 2018, when we nearly won the World Cup. And this is productivity. Productivity in manufacturing, 230%. So since 1966, we've got really good at making stuff, but we haven't got any better at building things. In fact, we've got worse at building things. So since we won the World Cup, we now make buildings more slowly and more expensively than we did then. I mean, this is obviously crazy. So we have this kind of craft-based construction process. You know, we always we use the example with our clients, if you turned up on site, if you bought a car and 2 guys turned up on your drive with a big box full of stuff and went, all right, mate, shouldn't be long. Like that. You would be concerned over quality and over program and over cost. And yet when you buy a new car now, you get a 6-year warranty. Imagine that in a building. So that's car manufacture now. Construction then, construction now. No change. So we've begun to realize that actually part of our process of building in timber is this idea of the industrialization of the construction process. And industrialization meaning better quality, meaning less risk, meaning better security and confidence in terms of price and program. So we started that journey with flat pack, so building in CLT panels, putting them on the back of a truck from a CNC factory, taking them to site, screwing them down into position. We've been doing pods for a while, so buying kitchens, buying bathrooms, buying utility cupboards from different places and putting those in as part of the construction process of the flat pack. And now what we're doing is working on volumetrics, so an understanding of actually being able to build boxes in factories, modular housing, which we can do in CLT, put that onto the back of a truck and crane it into position on site. So we're working with, currently working with 3 different modular housing factories. This one in Yorkshire, absolutely massive, that's a 17-acre factory. So the ambition for this is massive. And we have an incredible amount of housing that we need building in the UK, and we're just about to lose our construction workforce. So we really need to get this right, and we need to get it right soon. Now, one of the fascinating things about building modular housing from cross-laminated timber is if you imagine that a factory works by repeated process. So the CLT goes through the CNC machine in the same way each time. But the way in which that CNC machine is programmed, the drawings from the BIM programs that come through from our machines that go to the machine, mean that every time it goes through, it can be cut completely differently. So we can begin to make completely different modules within exactly the same process. Now, if you build a 2-bedroom apartment from CLT panels, you're looking at about 17 individual panels for those 2 boxes. If you do that in stick frame or light gauge steel, you're looking at over 500 components just for the structure. So that you can see that the opportunities for industrialization and the opportunity for error really don't exist in stick-based modular systems, in my view. And what we're able to do with this is begin to talk about choice. So we can actually talk to people when they buy their apartment. We can talk to them before they move in, and they can come into the showroom, whatever, and they can choose their kitchen. They can choose their bathroom. They can choose the color of their bedroom. In fact, what we can begin to do is to introduce choice. So rather than this sufficiently mundane white box that we're encouraged to produce, we can actually begin to produce apartments that people feel proper ownership over, that people feel as though they really are their home. Now, we've been doing this in cars for a long time. This is one of my favorites, the Mitsubishi GS platform. 14 models, all these different cars, all made with a Mitsubishi GS platform. Each one of these cars has over 1 million choice combinations, 1 million choice options. So 14 models, 1 million choice combinations from one chassis. So that's what we're beginning to talk about in terms of choice, in terms of modular housing. And we will be on site in February with this one here, so 65 apartments. And how many boxes? I can't remember. Yeah, 151 boxes, 16, so it's about 17,000, no, I'm not going to do that math. It's 250,000 square feet, so a big building here. And we've got another 4 of these that we're beginning to work on at the moment. We have projects now in Paris and in Stockholm in a similar vein. And then this year, I'm going to show you something we just had a bit of fun this summer. And we built this from tulip wood, from American tulip wood, the stuff that makes pallets and that gets pulped for cardboard, and actually I think often just gets thrown away. And so they came to us with this, and they said, we've got this. This was about January this year, and then we've got a spot at the Victoria and Albert Museum, which is one of the biggest museums in London, in their brand new courtyard, and we want you to come up with something between now and August and build it and open it in August. So we're like, whoa, better get this one right. And so what we began to do was to look at how we could make that timber into cross-laminated timber, how we could begin to use the kind of prefabricated methodologies that we're learning about in practice, how we could begin to use those with this hardwood CLT. And so we built these little boxes, these little models. We sent this to the V&A, and they said, yeah, okay, let's see what happens. And so we made some CLT in the UK. So this is the first CLT made in the UK, finally, after 15 years. So you can see being laid out by Neil and Douglas here. So quite homespun, but we're getting there. And then made these little boxes here. And then we shipped these boxes to London. And can you press play, please? Hey, thank you. And again. So 4 days, brought them in, little spider crane, lifted them up. These boxes are primarily 3-ply. So that's, what is that, 90 mil, 3 times 9, 27 plus 5, 20, about, not much. Less than 3 inches thick. No, sorry, just over 3.5 inches thick, CLT. And each one of the boxes has the loading capacity for 30 people. So incredibly strong little boxes. And you can see from the top to all these staircases that we put in the boxes. We piled them 3 high. And then over 10 days, we had 140,000 people running around these boxes. And we had 6.5 million impressions on Instagram. And the other thing that we did, even though we weren't allowed to, is that on the ground floor here, we surreptitiously at night came along and we screwed in information panels onto the ground floor here. And they talk about climate change and other really dodgy stuff like that. And they talk about the urban housing crisis. And actually, the amount of public engagement we got in this and the amount of public excitement was incredibly rewarding, because I think it's quite easy to stay in your little kind of architecture, construction industry world, but actually to take that out and to see the excitement of the public on this was just fantastic. So you can see people just running around it over those 2 weeks. So 43 cubic meters and 30 tons of CO2 stored within the material. So the installation is completely carbon negative. Even bringing it over from the States, manufacturing it in Scotland, shipping it down to London, and we still store more carbon in the timber than was used in that whole process. And now it's being taken down, it's going to Madrid, and then to Milan, and then to Barcelona. So we're already on the road, which is really exciting. And we're looking at other bigger projects in modular, this one up to 25 stories with Arabs, and we're pretty optimistic about that one. So what started for us with this low carbon buildings, the idea that we could build from replenishable materials, not materials that we scrape from the surface of the planet, but materials that we can grow and grow more of. That we started with an understanding that these were healthy buildings, buildings that people like living in, that are good for people to work in, and that these buildings, building like this, could help rural economies, that it could actually begin to make those links between city and countryside. And that these were beautiful buildings, so really solid buildings, not like the kind of dry-walled towers that we're putting up now, but actual kind of solid, meaty buildings, firm, functional, and delightful. And that this could be a factory process, that we could begin to industrialize with this, that we could increase productivity, increase quality, increase choice, and that this could be a repeated process. So we don't see this as a choice in construction materials. We don't see this as, you know, an interesting idea. We see this as a whole-scale opportunity for a construction revolution, that actually this must be the way that we build, not a choice in terms of concrete and steel, not just a viable alternative, but the only alternative, and the one that we all need to start building in all the time. And so we've written this book with the Softwood Lumber Council, which is about, we've now built over 600, not us, I wish, but in the UK we have over 600 CLT buildings. We've done a study of 100 of those buildings, and we've interviewed all the architects, all the engineers, all the clients. So this is a massive tome of a book detailing all those adventures and summarizing them in chapters afterwards. So available as a free download from thinkwood.com. And then this is my final slide. This is the number of tree seeds that it took to grow the trees that built Murray Grove. Thank you.